So today we start optical instrument. So before we start optical instrument, some very important part. This is an object. Suppose this is the height of the object. If we maintain the same height, but if we change the distance, so then basically what happened is, suppose here is a viewer जो इसको देख रहा है, यहाँ पे व्यूअर है जो इसको देख रहा है. If the distance increase, then the angle of observation decrease. Yes or no? যত distance বাড়বে angle ছোট হয়ে যাবে, হ্যাঁ या না?
Yes, sir. Yes, sir.
So for our eye, the minimum distance from which we can see our object very properly, that distance is called least distance of distinct vision, and that is 25 centimeter for human eye, and this is called the near point. And the from this 25 centimeter we can see the object up to infinity, which is called far point. So our eye is accommodated such a way that we can see an object from 25 centimeter to infinity. Means we can see an object at 25 centimeter, we can see the stars also, which is at infinity or very large distance. Now, this ability of human eye is called power of accommodation. Power of accommodation. Second important thing is, between the two pulse, suppose this is the pulse 1, this is the pulse 2. If the time interval between the two pulse is less than 0.1 second, we are not able to distinguish them separately. माने हमारे काछे अगर मेरे पास दो पल्स है, ठीक है, दो पल्स का बीच का टाइम 0.1 सेकंड से कम है तो मुझे वो दोनों पल्स कंटिन्यू लगेगा. और इसी को यूज किया जाता है मोशन पिक्चर में. मोशन पिक्चर में क्या होता है, रील होता है जिसको हम लोग स्लाइड मतलब लेंस स्लाइड करके स्क्रीन में उसको प्रोजेक्ट करते हैं. सो दो पिक्चर के बीच का टाइम अगर 0.1 सेकंड से कम हो तो हमें लगेगा कि दे आर इन मूविंग, मींस मोशन. इसी को यूज करके क्या किया जाता है, मोशन पिक्चर्स बनाया जाता है. जैसे तुम लोग एक मूवी देखा होगा तारे जमीन पे, जिसमें एक बच्चा ने बुक में बहुत सारा पिक्चर्स बनाया था, उसके साथ उसका मम्मी पापा का, और पिक्चर में वो अपने आप को धीरे धीरे साइड किया है. If you flip it, so you can see the boy is moving outside. Okay, so with the help of this, because of this things happen. Third thing is that if we have two separate objects, and if the angle between them is less than 1 minute, then we see them as single object. I repeat, if the angle between the two objects is less than 1 minute, we see them or we can't distinguish them separately. माने ये दोनों सेम ही लगेगा. जैसे मेरे पास मानो यहाँ पे एक स्टार है, यहाँ पे एक स्टार है. If the stars are very large distance and this is my earth, and if I am standing here, and for me, if the angle between these two stars, the angle is less than 1 minute, तो हमें लगेगा ये दो स्टार नहीं, ये एक स्टार है, मतलब which is called the twin star. Okay, तो ट्विन स्टार का फंडा क्या है कि दो अलग अलग स्टार जहां से हम देख रहे हैं वहां से उसका द एंगल बिटवीन देम इज लेस देन 1 मिनट। 1 मिनट मतलब कितना होता है? 1 मिनट का मतलब होता है 1 डिग्री का 60 पार्ट। ओके एवरीवन, ओके।
Yes, sir.
आफ्टर दिस, अब इंस्ट्रूमेंट का काम क्या है? इंस्ट्रूमेंट का काम ये है कि ये जो एंगल मेरे आंख में बन रहा था, if we try to, if we able to increase the angle, माने हम लोग अगर एंगल को इंक्रीज कर सकता है तो मुझे क्या लगेगा, वो जो पिक्चर था वो बड़ा हो जाएगा। ठीक है, सो दैट इज द मेन यूज ऑफ इंस्ट्रूमेंट। बाय यूजिंग द इंस्ट्रूमेंट हम लोग मेरे आंख के अंदर में जो एंगल घुस रहा है उसको हम बड़ा करने की कोशिश करते हैं, और जितना बड़ा करेंगे उतना टाइम्स ज्यादा देखेंगे। सो फर्स्ट इज सिंपल माइक्रोस्कोप। सिंपल माइक्रोस्कोप को मैग्नीफाइंग ग्लास भी कहा जाता है। सो मेरे पास एक ऑब्जेक्ट है, द हाइट इज h, यहाँ पे मेरा मानव व्यूअर था, मतलब द यहाँ पे मेरा आई है नॉर्मल। सो दिस डिस्टेंस इज लीस्ट डिस्टेंस ऑफ डिस्टिंक्ट विजन, LDDB, जिसमें हम ऑब्जेक्ट को सबसे बड़ा देखेंगे, दैट इज थीटा नॉट। थीटा नॉट और फोन असर पड़े, theta naught. So theta naught is h by d. That is the maximum angle by the normal human eye. अब देखो इसी ऑब्जेक्ट को हमें क्या करना है, सेम हाइट है। अब ये आई एंड ऑब्जेक्ट के बीच में इफ यू इंट्रोड्यूस अ लेंस, that f naught is the focal length of the lens. Now the ray diagram is very important, although for you people ray diagram is not required, but still देखो इसके लिए क्या करना पड़ेगा। ये मेरा प्रिंसिपल एक्सिस है, मिड पॉइंट है, ये मेरा प्रिंसिपल एक्सिस है, इसका एक पैरेलल लाइन ड्रॉ करो। ड्रॉ किया, और ये मेरा 2 पॉइंट, इसको तुम जितना दूर ले जाना चाहो ले जाओ, उतना दूर जहां तक रखना चाहो। सपोज हम लोग सोचे यहाँ पे इमेज फॉर्म करना चाहते हैं, इसको और ये जो पॉइंट है डॉटेड लाइन, देन अ डीप लाइन, और इसको डीप लाइन। तो द ऑब्जर्वर इधर से देखेगा तो क्या होगा, इस एच ऑब्जेक्ट को ऑब्जर्वर कहाँ देखेगा, एच डैश पे देखेगा, which is magnified. So this is the u। इसके लिए क्या कंडीशन है कि ये जो मेरा ऑब्जेक्ट है that must be within focus, क्योंकि if it is not within focus then the object of this one form in this side image, so then you can't see the object, first of all you see the object inverted। कभी कभी मैग्नीफाइंग ग्लास से पेपर को सामने रखना, and if you increase the distance you see, you realize the script of the paper it inverted। उसका जो लिखा हुआ जो है लेटर्स है वो उल्टा दिखेगा। that means the distance is greater than the focal length, so you have to adjust it so that it will be within the focus। ठीक है, so now as it is within the focus, if this distance is u, this angle is called the angle by the instrument or by the eye। Now so I can write it angle by the eye or angle by the eye through the instrument। So now my angle is h by u। So now obviously that means here we compare, this is called the angular magnification। So let previous हम लोग जितना भी मैग्निफिकेशन किया था, दिस ऑल आर द लीनियर मैग्निफिकेशन, जहाँ पे हम लोग लेंथ वाइज कंपेयर किया था। Here the magnification is angular magnification। So magnifying power, that is angle by the instrument, angle by the normal human eye. तो ये क्या आएगा? ये आएगा h by u, h by d. So क्या आएगा? d by u. That is the magnifying power. Yes, everyone. Yes or no?
Yes, sir.
Now जितना भी इंस्ट्रूमेंट है, सब इंस्ट्रूमेंट में दो चीज कॉमन है. द फर्स्ट वन, ओके, द फर्स्ट वन इज, अच्छा, एक और इम्पोर्टेंट चीज, हालांकि फॉर द सिंपल माइक्रोस्कोप यू हैव ओनली वन लेंस, but for the other instrument you have more than one lens. So in this simple microscope, this is the object, this is the eyepiece, this lens is behave like a same. So here we can use u, but from the next question everything is same, but instead of u, as we use the eyesight part, so we use u e e for eyesight. For this one we use u. Next सिर्फ उसको u को, u का जितना भी था u become u e, v become v e, f become f e, because we use the eyesight part. तो इसका दो होगा. फर्स्ट पॉइंट इज if image is at infinity, मतलब if the image formed at infinity, so 1 by v minus 1 by u is 1 by f. You can write e because I part, but here you can just write the focus. So v is infinity, u is in front, that is 1 by f. So you get u is f. ये इसके बाद से हो जाएगा u e f. Okay. And the case 2, these two are the same common. If image is at LDDV, so 1 by v minus 1 by u is 1 by f minus d minus u 1 by f 1 by u 1 by d plus 1 by f. So 1 by u f d d plus f, u is f d by d plus f, and you can use sometime this one also. Okay, everyone. Yes or no? Hello.
Yes, sir.
So according to my case 1, according to this, my case 1 magnifying power, that is d by u, u is f. Come when the image is at infinity, that means far point, case 2 near point, case 2 near point. Magnifying power d by u, u is what? d plus f by ft. So what you have? d by f plus 1. Yes or no? Tell me. Question number 1. Question number 1. If the focal length of a magnifier is 5 centimeter, calculate number 1 power of the lens. Number 2, magnifying power of the lens, magnifying power of the lens for relaxed and strained eye. देखो ये जो रिलैक्स है, रिलैक्स का मतलब तुम्हारा आई तभी रिलैक्स होगा when the object is in infinity, because तब आई पे सबसे कम प्रेशर पड़ता है, और स्ट्रेन्ड आई मतलब आई पे सबसे ज्यादा प्रेशर पड़ेगा when the object is at near point, means LDDV. Question number 2. Question number 2. A man with normal near point, a man with normal near point, 25 centimeter. A man with normal near point, 25 centimeter, reads a book with a small print using a magnifying glass, a thin convex lens of focal length 5 centimeter. Convex lens of focal length 5 centimeter. एक मैन है जिसका तुम्हारा लीस्ट डिस्टेंस ऑफ डिस्टेंस बिटवीन 25 सेंटीमीटर है, वो एक मैग्नीफाइंग ग्लास जिसका फोकल लेंथ 5 सेंटीमीटर है, लेकिन एक न्यूज़पेपर पढ़ना चाह रहा है. क्या है? Reads a book with a small print using a magnifying glass, a thin convex lens of focal length 5 centimeters. Number 1, what is the closest and farthest distance at which he can read the book when viewing through the magnifying glass? I think all of you understand कि दो चीज फॉर क्लोजेस्ट माने नियर पॉइंट, क्लोजेस्ट नियर पॉइंट में यू कितना है, फार पॉइंट में यू कितना है. व्हाट इज द क्लोजेस्ट एंड farthest distance at which he can read the book when viewing through the magnifying glass? Number 2, what is the maximum and minimum magnifying power is possible using the above simple microscope? So magnifying power, maximum, magnifying power, minimum. देखो closest मतलब your V is in least distance of distinct vision, and farthest when your U is infinity. Okay, so tell me the answer. See, for the first question, focal length is given 5 centimeter. They ask you the power of the lens. So power of the lens is 1 by f in meter or 100 by f in centimeter. So 100 by 5, that is 20 diopter. Yes or no?
Yes, sir.
Okay. Now the second part is magnifying power of the lens for relaxed and strained eye. So this is the relaxed when the image is at infinity. So magnifying power is D by F, 25 by 5, that is 5. And when the image is at near point, then this is this one. So this one, D by F plus 1. So magnifying power D by F plus 1, that is 5 plus 1, 6. Yes or no? Hello?
Yes, sir.
Have I বুঝেছিস? So I can remove the first question. Now the second question. What is the second question? A man with a normal near point D equals to 25 centimeter reads a book with a small print using a magnifying glass, a thin convex lens of focal length 5 centimeter. What is the closest and farthest? So it's a very simple. We use the formula 1 by V minus 1 by U is 1 by F. Now F is fixed for near point. For near. What do you mean by near? This is least distance of distinct vision. 1 by U, you don't know. F is 5 centimeter. So what you have, 1 by U, 1 by 25 minus 1 by 5 minus 25, 1 minus 5 minus 6 by 25. So U is minus 25 by 6 centimeter. Obviously negative. What do you mean by negative? What do you mean by negative? In front of the mirror. Yes or no? Tell me.
Yes, sir.
Now the second part of the question. What is the second part? This is for the far point. For near point. Sorry, this is for the near point. For far point. For far point, we use the same formula, but now the far point is infinity. Minus U equals to 1 by 5. So what you have, U equals to minus 5 centimeter. Yes. So you have 2 points to see the object. Matlab, to see the image is at infinity, you must put the object U equals to minus 5 centimeters. To put the image is at my least distance of distribution, U is minus 25 by 6. Yes, everyone?
Yes, sir.
Now the second part of the question, maximum and minimum power. Always remember the image, the power is maximum when the image is not the far point, when the image is near point. When the image is near point, in that time the eye is maximum opening, means the angle जो आएगा वो सबसे ज्यादा आएगा with the eyepiece. So see, maximum power, magnifying power, maximum के लिए हमें लेना पड़ेगा ये वाला केस, near point केस, मतलब d by f plus 1. So d is 25 by 1, 5 plus 1, the 6. सबसे ज्यादा मैग्नीफाइड हुआ. and magnifying power for minimum देखो d by f, so 25 by 5, that is 5. तो ये 5 times magnified, ये 6 times magnified. सबसे ज्यादा मैग्नीफाइड किसका होगा? 6 times. 6 times is the maximum, 5 minimum. और कभी कभी क्या होता है, अगर हम लोग इतना एडजस्ट नहीं करें, and but if you want to see them properly, so it is in between any value of u, but the u must be from least distance of distribution to infinity. So हमें basically instrument से range पता करते थे कि कहाँ से कहाँ तक देखना है. Okay, everyone. After that, the next one is compound microscope. Next one is compound microscope. So what happened in compound microscope? In compound microscope, you have two lenses. एक का फोकल लेंथ छोटा होता है, एक का फोकल लेंथ बड़ा. जो ऑब्जेक्ट होता है दैट इज इन द छोटा फोकल लेंथ की तरफ, और जो व्यूअर होता है दैट इज ऑन द बिगर फोकल लेंथ. So what happened if you put the object here first parallelly and इसको connect करके एक straight line. अब इसको इसका नीचे यहीं पे कहीं पे strike करो. Now this is the cut point. It's all about straight line, nothing more than that. Now as you have a straight line, this point and this point, तुम इसको कहीं पे भी रख सकते. Suppose I put it here. Now this point and this point, straight line. this point and this point. I can see the object here. If this is H, this is H dash, this is H double dash. Okay, everyone. Is it okay?
স্যার আরেকবার এক্সপ্লেন করবেন?
দেখ এখান থেকে একটা অবজেক্ট আছে, দুটো লেন্স আছে, one is the objective, another one is the eyepiece. Objective क्यों? Because on the side of the object. Eyepiece क्यों? क्योंकि जिधर पे हमने आंख रखा है उसको eyepiece कहता है. Now from this object you can put anywhere object. अब ऑब्जेक्ट का जो टॉप है इससे इस लेंस का जो सेंटर है से एक स्ट्रेट लाइन ड्रॉ करो. क्या? अंडरस्टैंड?
হ্যাঁ।
Now इसका एक पैरेलल लाइन ड्रॉ करो. ओके, नाउ दिस पॉइंट और इसका थोड़ा नीचे एक स्ट्रेट लाइन ड्रॉ करो by using a scale. So when you use this by using a scale, when you draw a straight line, একটা কাট পয়েন্ট আসবে, এক কাট পয়েন্ট आएगा, আসবে তো?
হ্যাঁ।
So this cut point and the center of this lens connected by the dotted line, এটাকে বাড়া, এটাকে যত দূরে বাড়াবি যেখানে ইচ্ছা নিয়ে যাবি সেটাই তোর ইমেজ. So इसको जितना दूर ले जाओ वही तुम्हारा इमेज है. So suppose we put it here. Now this point and you have 2 points, ये point और ये point, इसको dotted line से मिलाओ, फिर इसको आगे बढ़ा दो. So you get the ray diagram complete. Done?
হ্যাঁ, ওকে।
So now as this is my object, so this is my object distance and this is my image distance by the objective. Yes or no? It object distance and image distance. Yes or no?
Yes, sir.
Yes, sir.
Now, so obviously this one is my object distance for the eyepiece. Object distance for the eyepiece. As this is my object distance for the eyepiece, and here is a very important fact that you have to bring the object. देखो ध्यान से समझो. हाँ, इस ऑब्जेक्ट का इमेज ये रेड वाला है, which is dotted line. Okay, इस ऑब्जेक्ट का इमेज ये वाला है, बट ये जो इमेज है ये इस लेंस का ऑब्जेक्ट है. लेकिन कभी कभी क्या होता है, if you make it a large gap, so that means this object for the eyepiece is greater than focal length. So if it is greater than focal length, then the image is not in that side, image is in that side. We know for a convex lens, if the object between focus and pole, then and only then the image is in same side. Yes or no? Yes or no?
Yes, sir.
हाँ, so that means मुझे इसका जो इमेज फॉर्म हुआ इसको इसका विद इन फोकस लाना है, मतलब मुझे फोकस के अंदर लाना है, तब जाके ये इमेज इस साइड में आएगा. एंड आई कैन मेक इट बाय मूविंग दिस, जिसको बोला जाता है आई कैन मेक इट बाय एडजस्टिंग द आई पीस. तो एडजस्ट किसको हम कर सकते हैं? एडजस्टिंग आई पीस को करते हैं हम लोग. आई पीस को एडजस्ट कर सकते हैं. So by adjusting the eyepiece, we bring the image of the objective within focus of the eyepiece. Yes. Yes. Okay.
Yes, sir.
अब देखो ये मेरा जो है आईज के साथ जो एंगल होगा that is angle by the eyepiece. और ये ऑब्जेक्ट को हम लोग पहले भी देखा था by the normal eye, that is theta naught. ये d था, ये मेरा h है, so theta naught is h by d. And now what is my theta e? Theta e is h dash by ue. Is it okay? ये h मेरा नॉर्मल आई से था जब मेरा इंस्ट्रूमेंट नहीं था. नाउ I'm looking the same object with the instrument. Okay, so This is the angle by the instrument, that is h dash by u. Clear? And this length is called the length of the instrument, that is v naught plus ue. Why I put it in mod? कारण देखो ये वाला तो पॉजिटिव है, ये नेगेटिव है, तो ये टेंडेंसी होता है ये नेगेटिव है, तो यहाँ पे नेगेटिव लिखना, लेकिन नेगेटिव नहीं होगा, ये भी पॉजिटिव होगा. Is it clear? Now my magnifying power. What is the formula of magnifying power? Angle by the instrument, angle by the normal human eye. So angle by the instrument h dash by ue, angle by the normal human eye h by d. So क्या मिला? h dash by h, d by ue. अब ध्यान से देखो, h dash by h, ये इमेज, ये ऑब्जेक्ट किसके लिए? हाइट ऑफ द इमेज बाय हाइट ऑफ द ऑब्जेक्ट किसका है? हाइट ऑफ द ऑब्जेक्ट, हाइट ऑफ द इमेज किसके लिए है? ये h dash by h कौन लेंस के लिए है? इस लेंस का देखो ना, इस लेंस का, दिस इज द हाइट ऑफ द इमेज, दिस इज द हाइट ऑफ द ऑब्जेक्ट. यस और नो?
Yes, sir.
सो हाइट ऑफ द इमेज बाय हाइट ऑफ द ऑब्जेक्ट को क्या कहता है?
Magnification.
हाँ,
Magnification.
हाँ, किसका? ऑब्जेक्टिव का. सो आई कैन राइट इट m नॉट. व्हाट डू यू मीन बाय m? मैग्निफिकेशन. व्हिच मैग्निफिकेशन? लीनियर मैग्निफिकेशन. किसके लिए? नॉट. नॉट मतलब o मतलब ऑब्जेक्ट, d by ue. Okay. Everyone, is it okay? And length of the instrument is what? V naught plus ue. Now again you have two case. Case one, क्या था? The far point, yes or no? Hello.
Yes, sir.
And this far point only with respect to the eyepiece. So in the previous question, in the previous one, simple microscope, as you have only one lens, so we use one u, but now we have two lenses, so it is very important to specify this for who? For eyepiece. Yes, eyepiece. Everyone is okay? Eyepiece. So your final answer is eyepiece. This is E. Okay, everyone?
Yes.
So if I use the case one, my magnifying power is m naught d by, instead of ue we can write fe. Rest is exactly same. So L is what? V naught plus fe. Case two. Magnifying power m naught d. 1 by ue is how much? 1 by ue is d plus fe by fed. I can cancel dd. M naught d by fe plus 1. Yes or no? And in that case, what is L? V naught plus ue. Ue is how much? Fed d plus fe. Yes or no? A compound microscope has an objective of focal length 2 centimeter. Objective of focal length 2 centimeter, and an eyepiece of focal length, and an eyepiece of focal length 5 centimeter. Okay. If an object is placed at a distance of minus 2.4 centimeters in front of the objective lens, u naught minus 2.4 centimeter. If an object is placed at a distance of 2.4 centimeter in front of the objective lens, find the magnifying power of the instrument and the length of the tube. Find magnifying power and length of the instrument. Number one, if number one, final image is at infinity. If number one, V is at infinity. Number two, V is at LD dV. Is it okay? V मतलब समझ रहे हो? final image. Final image is at infinity, matlab far point. Final image is at least distance of distant region. Clear, everyone? Hello. क्या है आंसर? हेलो. हेलो. Am I audible? আরে কিছু বল. হ্যালো. শোনা কি যাচ্ছে? কিছুই তো বলে না.
First of all, focal length if not 2 centimeter and eyepiece minus 5 centimeter. Object distance is given minus 2.4 centimeter. So as we know the focal length of the objective, object distance of the objective, from these two data, I can find out 1 by V naught minus 1 by is 1 by yes or no? So 1 by V naught minus 2.4, that is 1 by F naught is 2 centimeter. So 1 by F naught 1 by 2 minus 1 by 2.4, that is 24 bar by minus dot 2 by 24, that is 1 by 12. We notice. Yes. So M naught is V naught, that is 12 by minus 2. তো কত হবে? মাইনাস কত যাবে এটা? Minus 5. Okay. Now the first one. D is at infinity. মানে it is at infinity. When the image formed at infinity, so that is the far point. So we can use magnifying power, that is M naught D by Fe. M naught is minus 5. D is, if you want, 25 centimeter, and Fe is 5. So minus 40 magnifying power. Length of the instrument V naught 12 plus UE. When the VE at infinity, when the V at infinity, UE equals to Fe. So UE जो था मेरा L is Fe, that V naught plus Fe. Fe is how much? 5 centimeter. So what is the length of the instrument? 17 centimeter. This is the first part. Now the second part, when the image is at LDDB, what is my magnifying power? Magnifying power is M naught D by Fe plus. So minus 5, 25 by 5, that is minus 30. And what is my L? Plus this one. So 5 into 25 by 25 plus 5. That is 12 plus 5 into 25 by 30. That is 12 plus 25 by 6. That is 5 by 6. 1 by 6 का 3 ना 1.16. 166. So 14.66. Yes, everyone.
Yes, sir.